All right. Hello, my name is Colin Bowen, and this is the Building Multi-Platform Experiences with Azure Mobile Services, Azure 316, just to make sure you're in the right place. Thank you very much for coming out and joining us, and hope you get something out of this session that you can take away to your own projects, whether they're personal or professional. I want to tell you a little story about I need slides up there. I'll wait for a moment because it'll ruin the surprise or the building of the story here. Great, there we go. So I want to tell you about this little toy that I got back in December. This was my Christmas present. It was a Tesla Model S. Is anybody not familiar with what a Tesla Model S is? Oh, good, we're all techies. Oh, there are a couple of hands. For those that you don't know, it's an all-electric car built by one of the guys that started PayPal. He's got one company that builds spaceships, another one that builds electric cars. But it's not just any electric car. It's won a ton of awards because they started out with trying to build a great car that just happens to be electric. 30,000 kilometers later, I got to say it's tons of fun. And I have absolutely no reason to go back to gas. Not to mention I've impressed a few Lamborghini drivers on the highway trying to outrun them. It is coming to Australia, good news, a little bit later this year. They just launched in Europe, and that was kind of from a design perspective, everything that they needed to do to come out to Australia. So if you haven't actually seen one in person, you'll be seeing them shortly as they make a lot of noise about it.
Can I just ask an off-topic question? What sort of mileage are you getting on?
Off-topic question? Absolutely, yeah. We won't make this all about the car, but we will because it has an API. But it's a car that can, rated-wise, it goes up to around 430 kilometers. Although a guy in Florida took one 600 kilometers on a single charge. So it's got more than enough for your daily usage. We've taken it on road trips. Like I say, we put 30,000 kilometers in about 8 months on it. So it's absolutely no compromises in driving electric. But what is really, not only was it just a fun car to drive, but as a developer, a couple months after getting the car, they launched a mobile app. And they launched this app on iPhone and Android, and of course they forgot Windows Phone. Somebody didn't give them the memo that Nokia and Microsoft were teaming up to do something really interesting. But what we discovered kind of through this mobile app and through a little bit of creative engineering is that this car actually ships with an API. And this API leads you to do all kinds of interesting things, not just read-only in terms of the data and state of the car, but also in terms of the actions that you can do on the car. And so over the last kind of a couple of months in between, kind of managing a 2-year-old at home, I've been starting to hack at basically creating a couple of apps around the car. And I want to tell you a little bit about those apps and what I've been doing with Azure Mobile Services and share a couple of tips and tricks along the way. This app will be something I'm looking to get into market by the end of the year. So if you're interested in putting a reservation down on a Model S and looking at getting one, we'll put some code up on GitHub that you can play with it. Again, it's one of those things where you never think you'd own one. I never thought I would own a car like this, but my God, best investment ever. Anyways, enough about the car. Let's talk about some code. So I wanted to actually start building some services around the API that comes with the Model S. And I needed to have essentially something that could do, for the types of services I wanted to do, something that would allow me to do kind of like a cron job style scheduled tasks, something that allowed me to store data in the cloud. And I thought, well, I could go out and spin up my own Azure VM and start writing my own server and things like that. But I didn't really want to spend a lot of time doing that because this is initially just a hobby. Who knows if I can turn around and make some money on this app. I want to do it as quickly as possible and with as little code as possible. And so I started looking at this whole area called backend as a service. And of course, it's everything as a service these days: PaaS, IaaS, et cetera. So this is just yet another thing. What backend as a service from a kind of a business area is trying to offer us as developers is the quickest way to get some essential services up into the cloud, and specifically around identity management, notification, executing and managing specific services, and storage in the cloud. So these are things that you could go and write code on your own to do, but why would you? Because this is just plumbing. So much like you would never go and say, I'm going to write my own grid control these days because the one from Telerik or Component One or DevArt is not good enough, you wouldn't go write something, for example, that did notifications, because they've already solved the problem of how do you do notifications across Apple, Google, and Microsoft platforms. And so that's really kind of the value prop of backend as a service. You can get access to these core essential services that are important in building not just mobile apps, but also building desktop apps for you easily. And of course, they make money on a per API call or per transaction basis. And a lot of these services offer also free tiers that allow you to get started. And that's kind of what I'm banking on, at least for the first couple of months of the Tesla Companion app being out into broad production out of private beta. So the usage scenarios for some of these back-end of service apps range from, like I say, your kind of simple data storage and notification all the way to vertical services. And for example, if you're building games or commercial services trying to do in-app purchases, some of these back-end as a service providers actually provide specific functionality around that. And that could be useful, again, for you to focus on just building what's unique in your app and less about building some of the infrastructure to support your app. And of course, there's a number of players on the market. This, in the last kind of 3 years or so, has become a bit of a space to play in. In fact, actually, a couple of them are ex-Microsoft guys gone out and supported it, or advising some of these companies. You got Telerik in the game with Icenium's Everlive services. So a lot of companies kind of getting into this idea of cloud services. Microsoft, of course, decided let's get into the game as well, and they launched Azure Mobile Services. And what's compelling about this is everything you know and love about Azure and Microsoft DevTools has come to the cloud. In addition, they've also embraced other kind of more web-centric technologies, like, for example, and we'll explore some of this today, some of the job scheduling stuff is written on Node.js. It's not C#, it's not VB, but they're trying to use something that's a little more scalable, asynchronous, and kind of cloud-friendly, and also in part to not limit themselves to just the tools they use. Or just the tools that they ship. So there's some interesting design choices in this particular service. Again, the appeal for my app here is just the broad support in the notification side, recognizing that I wanted to take this app and port it over to mobile using some of the Xamarin Stack, especially now that PCL and Async Await support has shipped, and try and get as much uniformity across the platform as possible. And that was kind of one of the end goals of this product and this offering, is to really kind of explore how to ship across all the different platforms. So getting back to the car for a second, this is a really interesting car. It's equipped with internet connectivity. It's always connected. It's got a 3G connection persistent in it. It's got a 4G chipset. The 4G upgrade is coming over the air somewhere in the next couple of months. And all access to this API is relayed through Tesla's servers. So I don't need to worry about somebody having an IP address to my car and hacking directly into my car. Everything's proxied through Tesla's services. And of course, they've gone and released Android and iOS apps, and that's great. There's an unofficial web app. In fact, somebody's even written a Google Glasses app for the car. But these apps are all great, but they really do just very basic stuff. They show status of the car. They allow me to unlock it and lock it. And there's so much potential left on the table. So the first problem we had to solve, though, when it comes to accessing the car is, how do I establish identity of you and the session to your car? So when I go ahead and log into the Tesla app on the phone or through the website, I've got to use my TeslaMotors.com account. And that's a great way to get into it, but that was really built specifically for Tesla building apps on it. There's no OAuth, there's no delegated identity. And so I needed to start by thinking a little bit about, how do I connect to that TeslaMotors.com account without storing username and password everywhere? For example, if I want to control this car from the cloud, I need some sort of authentication token to be able to control that. And so one of the things I started looking at in Azure Mobile Services was the identity use of things like Facebook and Microsoft account and things like that, in terms of how can I use that and having that login experience be fluid for the end user. And I thought, well, this actually creates an opportunity to say, hey, here, get some vanilla application functionality with your TeslaMotors.com account. But if you want these cloud-enabled enhanced services, log in with this additional account, and you'll light up some additional functionality. And so it was an opportunity to use, take a branding opportunity to differentiate yourself from what kind of comes out of the box with the Tesla Motors account. So what we did in here, and we'll take a look at this in code in just a second, is basically put an offer up there after you log into the app with your TeslaMotors.com account. Hey, if you want some of these extra services, no problem, just log in with a second account so that we can store the auth token that TeslaMotors.com generates, and then we can go ahead and access those services on your behalf. And that was really kind of important, is so that we wouldn't go ahead and say, hey, we're going to store your username and password in the cloud. We're going to use your token from your username and password session and store that in the cloud. So let's take a look at what's involved in getting that all up and running. So the first thing we've got here is I've just got the Windows Store version here that I'll be showing you. Don't look too closely at my XAML skills. I'm not a XAML slinger. I'm a web guy. But certainly if you're kind of hang out in the dev den tomorrow, I'd love to pick somebody's brain on XAML particulars. But I've got most of my service code hanging out in a PCL library, leveraging some of the HTTP client stuff, the async await stuff that recently shipped, and then of course my core application UI experience inside each of my UI projects. And so we've got a standard kind of Tesla service client class that goes ahead and accesses out to all the various Tesla services, and then I've built an enhanced services client which really wraps around the Azure Mobile Services. But the first thing before you get into the Azure Mobile Services is you need to establish some sort of identity with the cloud. And this is actually kind of important on a couple of levels. First off, there is an API key when you access the Azure Mobile Services, but because you're writing an app that's running on somebody else's device, you've got to pretty much assume that API key is not a secret anymore. It's just a way of accessing your account, and you can reset it if something really bad happens. But I'm going to be storing people's personal information, in this case, identity tokens generated off TeslaMotors.com, so I need to be able to protect those. And so I need some sort of way to be able to do that, and I'm going to use their social identity to do that. So let's go ahead and add in that step of going ahead and logging in as the user. So the first thing I'm going to do here is on the Enhanced Services Offer page. So this was just that kind of pretty little page before I showed you that will pop up and offer the user the ability to log in to get access to these additional services, is I'm going to make a call out to the Azure Mobile Services and ask it to log in with the provider that the user selected. Now, again, they've got 4 providers that they provide out of the box: Facebook, Twitter, Google, and Microsoft account. And so I've gone ahead and whatever button they pick, I've brought that back in through an attribute on the button and converted that to the enum. So now I can go ahead and just simply do Mobile Services Client is equal to new Azure Mobile Services Client. And I need to provide in 2 things. One is the URL to my Azure Mobile Services endpoint, and you get this when you sign up and create your service. The other thing is you'll need is your API key. Again, like I say, the API key isn't really a super secret. It's just a way of kind of saying your stuff isn't open to the entire world. It at least is constrained, but you've always got to assume that your API key is not necessarily a security mechanism. The next thing we'll do is we'll ask the user to log in, and this is where the Azure Mobile Services client-side SDKs provide you functionality to be able to do that. And so I'll go ahead and just say log in as sync. I'll go ahead and pass in which provider that I want them to use, and that will return back to me a mobile services user. And so this isn't actually returning back to me the Facebook token or the Twitter token. It's passing back to me an Azure Mobile Services token that encrypts and wraps the underlying Facebook OAuth token. So I never have to deal with the specifics of Facebook or Twitter or whatever. It's just a user, they're authenticated, and then Azure Mobile Services handles it from there. And that's something to kind of be aware of if your app wants to take advantage of specific services inside each one of those social networks. The token that you're getting back is not actually going to allow you to go out and reach out to Facebook and do anything specific with Facebook. Well, let's go ahead and store that inside the app, the user identity, so that the app can relaunch and save and relaunch and not have to ask me to log in again. Now, one other thing to keep in mind is what happens when the user hits back on the experience or cancels the experience. Unfortunately, I'd love from an API perspective that login as sync would just return a null, and I could gracefully handle it. Unfortunately, they've decided that exception throwing is the way to handle canceled actions. And unfortunately, it's a very undescript invalid operation exception. So we'll go ahead and catch that, and we'll just do a check to say if the message contains canceled by user, and of course we'll do our, we'll assume no case. Oh. Uh-oh. Dun, dun, dun. This is the problem when you run preview bits on preview bits. Let's assume that's going to die. In fact, we'll kill it, and let's just launch another one here just quickly. What I'm basically going to do is catch that exception, check for the message, And I'll just go ahead and do my cut and paste this time so you don't need to rewatch me retype that. What this is going to do is going to log in, get my token, and then catch the exception if somebody hits back, and then allow the operation to continue. Otherwise, rethrow the exception if it is truly an invalid operation exception of another sort. All right, enhanced services. And so once I've got that code in there, I just need to simply go ahead and insert that into the operation and make sure that gets called. So when users come into the app, I'm going to check to see, hey, is the app configured? If not, go ahead and prompt them for their user credentials, initialize and authenticate them, and then go ahead and configure the app. However, if they are an existing user and I've got their identity, go ahead and reinitialize it off the last session and allow me to continue on my way. So we'll come back here and say pop-up helper is equal to new pop-up helper for the enhanced services offer. And we will do await show sync. Okay, so let's see what this actually looks like before we add some of the Azure mobile services, the further gravy for getting me up and running. So launch the app. Don't focus too closely on the skin of the app at the moment. So the first thing it's going to do is prompt me for my TeslaMotors.com account. I do not have that in a notepad just to keep it nice and safe because it does access a real car. And we'll go ahead and log in. And so the next thing I'm prompted with is this enable enhanced services. And again, this was a design decision. Instead of having basically me log into my Facebook account and then, or my Azure Mobile Services identity platform, and then the Tesla Motors, we decided to basically present it as, hey, here's a standard app that will allow you to do read-only stuff, and it's specific to your device. But if you want the cloud enabled, you log in here for some extra fun. And so, just trying to put those front and center, and always offering an opt-out option for somebody who doesn't want to use all those enhanced services. So let's go ahead and log in with the Facebook account, and you can see the experience here. Basically, it's a web view wrapped up inside a Windows dialog here. And so you can go ahead and just log in as you would normally with Facebook. And again, we'll just copy and paste the password here, because I can't remember that long of a password. And we'll go ahead and save the browser. And then Windows will then go and offer you, do you want to save the credentials in its credential store and have that synced across PCs? At this point, I'm going to say no. And in a second here, it's going to start to launch the car. And I can see my sister-in-law, who currently has access to the car, has left it parked but unlocked. No problem. We'll deal with that a little bit later. So now we're into the app, and we effectively have this session, and we've authenticated into the cloud. But really what I want to do to be able to take advantage of the cloud is store the authentication token that comes out of the Tesla Motors sign-in. And again, this is not the username and password. This is just an encrypted hash value, blob, whatever you want, that represents the sign-in session. And I want to store that in the cloud as opposed to the username and password, because I always want to do the best thing for my user and not store things that could hurt me later on in terms of if I were ever to get hacked. Luckily, I watched Troy Hunt's OWASP Top 10 and learning a few tips and tricks about that. So the next thing we're going to do is store that session into the cloud. So this is where some of the Azure Mobile Services stuff from the data side comes into play. So the first thing I want to do is create the session table and start storing stuff in that session table. And so I'll go into my Azure Mobile Services, I'll go into my data tab here and create a new table, and we'll go ahead and call this sessions. Now, I'm going to set up all these permissions here, and this is where I'm saying kind of the application key and everyone are kind of one and the same thing. If you assume your API key has been leaked, you really want to think of these as about the same thing. In other words, it's completely public access. But in this case, we want to make sure that the session is only accessible to the individual user who added the row. And there's a couple of ways to do that. One is through table scripts, and the other one is through creating a custom API. We're going to explore both. So in this case, I'm actually going to do it through an API, and I'll explain why. It's because I really only want to hold one session associated with the user. I don't want to hold 5 different sessions. So if I log in with my phone, my Surface, and my laptop, I really only care about storing the most recent session that has been generated by the user, because that's going to be the most fresh, and that chances are that hasn't expired, so I don't have to spend as much time dealing with expired sessions and notifying users of expired sessions. So I'm going to actually implement the entire session storage using the API functionality, which gives me a little more fine-grained control over the behavior. So what we'll do is we'll set this up so that this table is only accessible by scripts and admin. And what this will do is go ahead and create me a table. And in a moment here, it'll come back and say, yep, we're, oh. Somebody's spreading the word. Luckily, I didn't flash the address of the unlocked Tesla. It'll be otherwise a big Easter egg hunt back in Canada. So when you get into the table view, you'll see here, I've got just a basic table with an ID column. But unfortunately, the UI doesn't give me a way to add columns to the table. And that's because out of the box, Azure Mobile Services is trying to promote, hey, this is kind of a dynamic thing. You just post data here. We'll guess at the columns and add those columns as necessary. And you can turn that functionality off once you get to kind of a production state and you want to lock down your schema. But it's really not handy when you want to create a table and you want to kind of define the schema and then access the table through a way other than through the table APIs. The good news is that under the covers, Azure Mobile Services is simply just a SQL database for the data side. So what I can do is I can connect using any sort of SQL Management Studio, or in this case, the inbuilt SQL Server Object Explorer that's shipped with the SQL Server Data Tools, and go ahead and actually connect up into the cloud. And what that's going to do is allow me to graft on a couple of extra rows of schema to the table. In this case, I want to store, and I'm just not going to type this out here, I'm going to store the authentication token, the expiration date on it, the session token, which is kind of a companion piece. Don't ask me, it's Tesla's design. And then who the owner is. And the owner is the unique user identity generated by the Azure Mobile Services side to kind of figure out who that person is. So I'll go ahead and alter that table and add that schema. And if I go back here into the cloud view, and I just do, I guess I'll do a refresh of the page. And you'll see in a second here that I will have a table that will have some new and additional columns. Come on, cloud. Somebody scale up the management portal with a few more VMs. All right, there we go. So we've got some additional columns there. I'm off and running. So now I need to create that interface for the table. Now, as I mentioned, I wanted to do something unique with the sessions table. I don't want to trust that my app will, even though I write the app, I don't want to trust that my app will actually handle the behavior I want around storing of sessions. And so I want to create actually what looks like more like an endpoint, like just a regular API to access sessions. And this is the thing that I'm kind of keeping in the back of my mind. Even though I'm writing an API and it's my applications that will be hitting it, I want to assume that somebody else will somehow have reverse engineered my app and figured out how to get access to my API. So I've got this business logic that says, I only want to store one session, and it's got to be whatever the most recent session you sent me in. If I implement that entirely on the client side, first off, I've got to implement that on the phone, each phone platform. I've got to implement that on the tablet, on the desktop app, on the web app. I've got to implement it all over the place. It's easier to go ahead and wrap that into a custom API and then let the users access that API and really kind of centralize that behavior. So here I'm going to go ahead and let the authenticated users go ahead and get their authentication token, put in a new authentication token, and then go ahead and delete their authentication token if they choose to sign out. So what that's going to do is going to create me essentially an endpoint, a /session API that I can now go ahead and perform those HTTP operations against, and then give me the ability to really do whatever I want when those requests come in. So like I'd mentioned, Azure Mobile Services relies a lot on Node.js and JavaScript. And as a web guy, it's like, hey, that's kind of cool. I'm comfortable in JavaScript. Let's have some fun. So they give you a full editor here. Well, not a full editor. You don't quite get all the IntelliSense that you get in Visual Studio, but a pretty decent editor here in the cloud that they've been working on. And it looks really simplistic at first until you realize it's got hotkeys and things like the ability to highlight and do some very basic kind of refactoring. Inside the IDE. They spent quite actually a bit of time thinking about this. So it's actually a nifty user experience. But if you don't like this, you can always actually do a git pull and pull the repository where your scripts are stored down and do all your editing locally. But for today, we'll go ahead and do our editing here in the cloud. So you can see here, it's already set up my get and post, and as well, I got to define a delete function. So just in the effort of time, because this is a bit complex logic, I'll paste in the logic for the get, and let's walk over what it's doing. So here in the get, I'm going to go out and actually get the MS SQL driver, because I mentioned the database is really just SQL. I'm going to get the user. I'm going to get some date information because I want to store everything in the database in universal time. And I don't. The clients are always going to hopefully interact with me in universal time. So let's evaluate everything based on universal time. And I'm going to issue a query in the cloud. And so it's simply just going to say, go get me the latest session. If this session is newer, persist it to the database. Otherwise, tell the user, hey, I've got it. I've got it, and it's not found. Give me the latest session, and make sure it hasn't already expired. And if so, return it to the user. Otherwise, tell them it's not found. Now, important to know here, all the good practices of SQL still apply in the cloud. No string concatenation to create SQL injection attack opportunities. You should be passing in parameterized SQL, which is what I've done here. And then you deal with a callback for success or error to deal with the result set. The next thing you need to do is support the put function here. And I still got a to-do note because I am still kind of poking around at this Node.js implementation. But the ability to go ahead and validate requests, kind of what's the best approach. And so as I mentioned, this app is a bit of a learning lesson in terms of how to best do this inside the cloud. And we're trying to figure out still what Node modules are all installed on the box. But basically here, I'm going to allow the person to put the session in. And what I'll do is I'll make sure if there is a newer session in there, to just go ahead and ignore the request and tell them, yep, that's fine, whatever. But otherwise, if this session that you've given me is newer, go ahead and delete all the sessions and then insert this session back into the database. And so actually here I've gone out and used the table API to be able to do that as an alternative, just to show you that there's kind of two ways to insert it. The table API is going to take the JSON request, and as long as it maps exactly to the schema, be able to insert it into the table at the other side. The final thing we'll do is support the delete function. And again, this is something where you could have written this all through the table scripts, because each of the table scripts allow you to do read, update, insert, and so on. But what's different about this, and why I wanted to do it through the API, because there's a little bit of semantics. When I go and through the table scripts, I'm effectively calling /get/sessions, plural. And if you're at my API talk a little bit earlier today, you know I'm a bit finicky when it comes to URLs. And when I do a post and a get to get sessions, it implies that I could potentially get a collection back. Whereas I'm saying for this interface, I really only want to store one session, and I always want to return just one session. So I'm creating an API called /session singular. And so it kind of implies by its very nature that you're always going to be dealing with, from the client perspective, a singular session. So we'll go ahead and save that API, and then let's go ahead and add the hooks in the app while that's saving to be able to take advantage of that. So just to kind of show you how easy it is to interact with APIs in the cloud. First off, you can either hit it up directly, and there's some guidance in the documentation on how to construct the exact URL, or you can use the client that comes with Azure Mobile Services. And it's a very simple client to basically invoke the API using an asynchronous method. And in this case, I just have a constant string that stores the word session. And then pass in your data in JSON format. And so you do a get, a put, or a delete using this invoke API sync. So really, really simple methods for accessing it. If you don't like this Azure Mobile Services client for doing this, you can go back to your standard HTTP client and access it as well, because it's just doing JSON over HTTP. So let's wire up the actual storing of the sessions, and then I'll show you a stored session, so you can get a sense of what it looks like. So once I've got the session, when the new user's logged in, we'll just go ahead and spark up a new mobile services client, activate my enhanced services client, which uses the mobile services client, and it's going to go ahead and get the session from my previously initialized Tesla service and store that in the cloud. And of course, we'll do that as well for logged in users. And this one's kind of important. Every time you come in, your Tesla session may have expired. I'm going to go ahead and detect that, re-authenticate you, and then have it restore that session up in the cloud. So let's go ahead and do that now. So we'll just relaunch the app. I've already logged in, so it's going to go through that second code path. And in a second here, as it pulls everything up, I'll know that it's completed that code path. I'll be able to go back to my sessions table. And I should hopefully have a row in here. with a bunch of information. Try not to take pictures of my session token. I will expire it after this talk. In fact, actually, I don't think it shows the full one good. So you can see here, actually, so it's worth kind of spending just a quick second here. So there's my Tesla info in the middle. It's all just gobbledygook. But there's my owner ID up there. So it just says Facebook : blah, 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 blah. That's not the Facebook OAuth token that's returned to the Azure Mobile Services. So this is what I was saying. You really can't do anything with that. That's just for you a unique identifier for that user. So kind of keep that in mind if, when you're looking at, a lot of these back-end as a service offerings kind of follow a similar model. And their goal is really to abstract you, so you don't have to care if it's Facebook. But if you want to build an app that uses it, but also provides Facebook capability, you're in a bit of a bind, at least at this current moment. I know certainly there's a lot of desire to enhance this service, so I'm sure if enough requests come up on the user voice, things will change a little bit on that. So what I learned from building this out are a couple of things. First off, I'm a big fan of test-driven development and making sure that I understand what it is that I'm coding. And so as I was writing tests against this, I wanted to obviously add some integration tests to make sure that when I logged in, that it was actually persisting the session and so on. And I had to do that without any user interaction, because if you're writing a unit test suite or an integration test suite, the last thing you want to do is hit run and then have a user actually go and plunk information in there. And so I was able to actually recreate the equivalent of the Azure Web Token, the authentication token, because it's actually just a JSON Web Token. Again, as I mentioned, they were trying as they're building this to follow the web standards that exist out there and not invent things where they needed to. Now, the kind of key to kind of keep in mind is that if you're going to do this, is that you need your account's master key. Now, that's a key you don't want to share anywhere. Because once you have that key, you can authenticate yourself and recreate users and so on. And so, my best advice is when you're doing testing or anything around the account's master key is just create a second instance of Azure Mobile Services, not your production instance. And so once you do, you create that JSON Web Token, you sign it with your Azure Mobile master key, and then you can go ahead and provide that through a header, and you can make calls completely without the SDK. And so that was useful for me to test a code path that goes through the SDK, but then clear out the table by making just a straight call to the REST endpoint. Now, this is really interesting because they are using JSON Web Tokens. There's this theory essentially that you can now extend and go beyond the ecosystem of Facebook, Twitter, Google, and Microsoft to other identity providers. In fact, actually, a company called Auth0 has gone one step further and said, well, if you like Azure Mobile Services and you want to connect it up to your organization's Active Directory account, no problem. We've got that covered. And so they've leveraged the fact that it's all claims-based identity using this JSON Web Token and allowed you to go even further. So don't think of back-end as a service as something that's purely for the consumer space. This is something you can also extend into the corporate and private ecosystems through other services they've written on it. Now, kind of the key here, of course, is to make this all work, you have to give guys like Auth0 or that service or that application your master key. So again, don't treat that too heavily. And of course, because you're there, now you can do things like multi-factor authentication for corporate using the recently announced Azure multi-factor authentication, that's a mouthful, services that are available. So identity here, like you say, on the covers, you're going to see, oh, it's the social stuff and it doesn't apply to me if I'm doing corporate apps. But the reality is that they've just really built the foundation on good web standards that make it possible to extend it out. And hopefully out of the box, they'll support things like Azure Active Directory in the future, so you don't even have to go to a third party necessarily to get some of that corporate support. So the next thing that we wanted to explore was kind of how location services worked within the cloud and what sorts of things we could do around that. And so one of the more interesting things were things like charging stations. So as somebody driving an electric car, it's one of the things you get used to fairly quickly is that you can't stop at a whim's notice and just simply fill her up. At least not yet. Tesla's shooting for the 5-minute recharge by the end of the decade, and if they make that, it'll be a whole different ballgame then. But in the meantime, charging stations are somewhat important, and you're going to learn fairly quickly as a new EV driver that not all charging stations are created equally. Not all of them provide kind of the largest number of amps to your car. Some of them are in restricted locations, and some of them are just in plain old undesirable locations that you want to leave your car for a couple of hours to charge. And so it becomes important to start taking that list of charging stations and whittling it down to places that I trust, places that have the highest capacity charging charging capability, and places where I can go actually find something to do for an hour or two while I plug in. And so what we want to do is combine the service of Open Charge Map, which has the listings of all the charge points out there, and the idea of essentially creating a favorites. But again, I couldn't, kind of like the TeslaMotors.com scenario, I can't go and ask Open Charge Map to change their functionality to suit me. So I used Azure Mobile Services to effectively mash up what I get from Open Charge Map with this idea of a favorites charging station. And again, just doing that through table-based storage, storing for each user what their favorite charging stations are. So this kind of is a little more about using just straight the table services in their purest form. So let's take a quick peek at how that all comes together. So what we want to do is we've got a list of charging stations that comes up in the app. We'll show you that in a second. But I want to be able to store essentially my favorite charging stations. So let's go ahead and create a table again, favorite charging stations. And this time we'll go ahead and allow everybody to go ahead and access this. They'll be able to, they won't need to update it per se. We're only going to, either you add it or you remove it. So we'll just leave that to scripts or admin. We'll allow people to remove, insert, or delete their favorite stations there. And so this is going to go out and create the table. And SQL's churning away. All right, perfect. And we'll go in and browse our table. And this time, we don't need to add the schema because we're going to directly access the table API. But I need to do a couple of things to make this effectively a place where users can store their own personal information. So by default, the table script for insert, update, and delete are actually just going to execute that operation. But there's no distinguishing of which user is actually doing that. So for example, when I insert, I want to make note of who the user is and make sure that that gets recorded into the underlying table. So in this case, I'll say for the item that you're about to insert, which comes in through my insert here, I want you to basically add a user ID column and make sure that the user ID is added to the item. And so again, this way I'm not relying on my end device, which even though I built the app, I still don't trust because somebody could hack my API. I'm letting my server make the final call on that. And again, really important, like I say, I can't emphasize this enough because I've just been into enough companies, seen enough code where people assume that because I wrote the app on the client side that somehow my server is safe. As Sony learned with the PlayStation network last year, I think it was, just because you shipped and manufactured the device, you can't assume the API is going to be used diligently. So the next thing we need to do is also make sure when you query that you only get the stuff for your specific user. So in this case, what I'm going to do is I'm going to actually append to the existing query, which is coming in through my query, and say that I want my user ID equal to my user.userid. And this is a bit of, for those coming from the C# world, this is JavaScript. It's a little new, unfamiliar. Absolutely, we don't have IntelliSense built into this yet. I'm sure the team is probably interested in how to make that happen. But there's certainly plenty of examples to show you a little bit about the query API, and there's more documentation and examples coming over time. But actually, if you do get into this, I'd really love one of the user voice requests for mobile services that I voted for, and I encourage you to vote for, is a local dev instance of mobile services. So we'll talk a little bit about the user voice thing at the very end and how you can help out. So that one's really easy. When you go ahead and read, make sure that the user is there. Now, when you get to the delete operation, things get a little more hairy because deletes aren't exactly as straightforward. I can't really append to the query the actual delete only where this user ID is. And in fact, actually, I probably don't want to do that. I probably want to actually be a little more verbose in my API and say, hey, if you try and delete something that's not yours, I want to tell you that you tried to delete something that's not yours. Or if you tried to delete something that didn't exist, I probably want to tell you that. So we're going to add a little more verbosity into that particular one. So let's go ahead and get the current table. And let's actually do a query into the table. And I want to say where the ID is the object that's being, that I'm being asked to delete. And I want you to read that. And when you do, let Let me just make sure I get my brackets here correct. When you go ahead and get that object, I want you to run a function with the results. And now I want you to, if you get results back, then I want you to go ahead and check the user ID of the item. So let's, again, I could get multiple results back, but at this point, I'm assuming because I'm asking for a specific ID and that's the primary key, that I'm going to get only a singular result back. And now I can inquire if that item.userid is really equal. And if again, for those that aren't familiar with JavaScript, 3 equals means that not only is the number equivalent, but the data type is also equivalent, user.userid. Only if it's very equal, then I want you to go ahead and execute the request. So this ensures that basically when you ask me to delete items 1, 2, 3, that it's actually owned by you and it actually exists. Otherwise, I want you to go ahead and change the behavior. I want you to go ahead and respond that the status code with the status code forbidden to say, hey, hang on, you tried to delete something that's not yours. So or say, hey, not your record, eh? Add my little bit of Canadian in to that. And otherwise, what we can also do here is say, else. Oops. We can say, hey, if the record didn't exist, we can say request.respond with status codes not found. All right. So the other thing as well we can do is we can also handle error conditions. So there's, if the query went wrong for whatever reason, we could come back and respond with a 500 error code. We could also go ahead and just say not found. Again, it's up to you to define the behavior. But the kind of the thing I want to get across here is that you can change the behavior of the get, put, and post into table operations with some fairly simple code and enforce certain business rules. And you want to do that on the server side. And that's why it's important that these guys aren't just providing a straight up, here's a SQL connection, go ahead and post data into the cloud, but they're actually providing you a pipeline which you can extend with your own functionality because your API is really a public endpoint for your application. So back in the app here, the actual charging station is represented. So we're going to use the actual table APIs. So I've got a charge point, a favorite charging station object where I store the ID of the record and the actual charge point ID. I don't store the user ID here because my cloud stuff handles that. I don't need to worry about. But one of the kind of interesting things that I kind of stumbled over as I was doing this is the fact that, in my domain, I'm calling the object a singular value, favorite charging station. And when I go to post that to my collection, it knows it as favorite charging stations, plural. And the API that is providing the Azure Mobile Services doesn't actually know how to do that pluralization. So I actually have to add an attribute if my table name and my object in my underlying code doesn't match up to kind of say, hey, by the way, when you get this object, store it inside this table. And so it allows you to rename the table, but more importantly, in these situations where you want to keep your domain nice and clean, you want to keep that, you'll need to go ahead and provide that little bit of intelligence. So let's look at the Azure Mobile Services API. Now, remember before we were using the invoke API async and just passing in a blob of JSON. This is actually the table API itself, and just to show you how it changes things a little bit. So first off, you go and get the table, and I don't specify a name. I just say, get me the table for this type, and it will infer the table name off that attribute that I provided, and then allow me to do stuff. So in the insert scenario, it's really easy. Just insert, pass it in the entity, I'm off and running. No different than working with something like Entity Framework or in Hibernate or so on. And likewise, on the select side, I can get my full link access into it. ... almost. Underlying the covers here is actually an OData call. And so depending on what you're doing inside your select lambda or your where clause, for example, down here in the remove, there are things that will not work because ultimately this is translating into an OData query string. And so if you're doing some sort of internal .NET operation, the API will balk at you and say, hang on, that's not supported. I can't translate that into an OData query string. So just kind of keep that in your mind, that actually when you're using the table APIs, you're actually hitting an OData feed to that service underneath the covers. So now let's go ahead and add the code for the the adding of the favorite. Nothing too crazy here. Hey, got to turn off my tweet notifications. We'll worry about that later. So again, don't look at my XAML code here. This is nothing too pretty. But the first thing we're going to need to do is, again, remember I mentioned that you can opt out of accessing mobile services. And from an app design perspective, you always got to think about, if I'm building an app that has regular functionality that can work without the cloud, I should offer that option. So if they're going to hit this button, I need to be able to make sure that the user is actually enabled for the enhanced services, and if not, offer them another option to sign up. And this is really my kind of trying to keep teasing people into signing up for my enhanced services, so that maybe potentially I could monetize it in the future or whatever. So I'm not going to hide those options just because they opted out. I'll just make sure that when they click them, that I re-offer the services. And then the next thing I'll do is go ahead and save it out to the cloud and then pop up a toast notification in there. And again, I get really simple API. Just go get the current item, grab the ID off of it, and call my API to save the favorite charging station. And the rest of this is your good old XAML gobbledygook for doing a toast notification. Someday, hopefully, they'll make it a little more straightforward. All right. And then likewise, I also have to get the ability to be able to view my favorites. That would be nice. And so we'll go ahead and because I've already got the API and the enhanced side, I will go ahead and do that. So I'll do my offer again, go get the list, and post that to the client. So again, this isn't, the XAML stuff isn't really the focus here. It's more about kind of how to use the mobile services piece, partially because I'm a web guy, not a XAML guy, and I'm still learning XAML. I'm sure there are other sessions that will talk to you a lot more about XAML. So I've logged in. Again, it's already got my session saved, so my experience is nice and fluid. I'll pop into my charging station. I've clearly got some resizing to do. And we'll pop up. We'll come back to unplug notifications a little bit later. We'll go to my charging stations here. And the one piece, and if any of you are XAML experts, again, love to hang out in the dev den. I've got questions about how to do progress indicators in XAML that I'd love to pick somebody's brain on. But it's going to go out and find my stations, and I haven't done anything too fancy with this, but just to kind of give you a sense of the type of data that I get back about a charging station, I actually get quite a bit of data. I know things like what plug type it is. I've got comments, I've got connections. I know who operates the plug. Some of these charging stations have started to also go pay, which is actually not so bad because it cost me about $5 to fill up my car effectively. So I'm happy to give them $1 to recharge it or two. So let's go ahead and add this to the favorites, and we'll go ahead and add, let's try this 900 Maple Avenue. And then I'll go ahead and view the favorites, cross my fingers, hope everything goes all right here in the open charge map. So what I've done is I'm going out to Azure, getting out that list of identities, and I'm going back to open charge map and going and getting that list, if the demo gods are on my side. Oh, unfortunately they're not. Wah, wah, wah. This is actually not an Azure problem. This is the Open Charge Map API, and there's sometimes sending me some gunk back, and I haven't been able to fully figure it out. So there you can see the issue is actually in WCF data services. So I apologize for that. We shall move on, but actually let's go ahead and take a look at the API, the table data, just so you can see that there's actual real data in there. Voila! There's data in there. Now, that's all really kind of fine and dandy, but there's still even cooler things I can do with Azure Mobile Services. But before I do, I just want to kind of mention, so the table APIs, just kind of keep it in the back of your mind. It's kind of a dynamic schema, kind of NoSQL-ish, but it's not. It's still hitting a SQL server under the covers, and so when you get ready to go to production, you can lock that dynamic capability by flipping a switch in the portal. The pipeline is extensible before it gets to SQL Server, and that's actually really important because you don't really want to open up port 1433 and give everybody direct access to your database because you can't trust your device. And you can also just completely ignore the table APIs and do your own thing in Transact SQL. So it is a full SQL instance behind there, and so anything you do in SQL Azure, you can do with the Azure Mobile Table Services because they're really just one and the same. So the final thing, final kind of feature I was building around this, and this to me is the one that has the most potential. And I'll tell you a little bit about it. Is things like being able to take data, take it with the internet, and do some really interesting things. In this case, I learned kind of the hard way that plugging in your electric vehicle at night is kind of an important thing. Back home in Canada, we've got this concept of on-peak and off-peak hours for electricity consumption, and the idea is basically to drive down electricity demand during the highest use hours of the day, and so they do that through financial incentives, to the point where it's basically about half the price per kilowatt hour to draw electricity after 7:30 at night. And so I came home at 4 o'clock. I thought, oh, I'm home early. I'll plug the car in a little bit later. Get up the next morning, go out to the garage. Oh, crap, I forgot to plug in the car. And, I had enough kilometers to get to my client, but not comfortably. And so I thought, oh, I'll work from home today. So it worked out in the end for me, but that's not always the case. Sometimes you do need to remember to plug in your car. Now, since I started building this feature, Tesla's actually shipped a scheduled charging feature that allows you to plug in, and it will know to wait till 7 o'clock to start drawing energy. But I still think this is actually kind of useful because you still could forget to plug it in. And so I want to build a feature that will allow me to say every night around 7:30, just check that the car is actually plugged in or charging. And if it's not, send me an alert to let me know that the car is not plugged in so I can go out and actually plug it in. And so this allows you to kind of use a little bit of that cloud and a little bit of that API and bring it all together. So basically what I did is use the scheduled jobs feature in Azure, and every 15 minutes I basically get a list. And 15 minutes was chosen because that's the smallest interval of time that the scheduler will allow today. Go get me a list of vehicles that need to be checked since my last run. Then go ahead and query each of those vehicles and make sure that they're actually charging. And then if they're not, then go ahead and send me a notification on any one of my devices to let me know that it's not plugged in. So let's go ahead and take a look at that functionality in action. Oops. So this one's a little more involved in the sense that I've got a couple more moving parts to this. The first thing I need is a table to be able to store where I'm going to be looking for the charge state notifications. So let's make sure I spelt that right. So what I'm going to do is I'm going to run this all through the scripts as well, because I've got a couple of things that I want to be able to do with that. So we'll go ahead and set that table up. And because I'm going to be doing it through scripts, I don't have an opportunity through posting an object to it to define the schema. So we'll go ahead and define the schema back here on the database itself. So let's go ahead and do a new query. And I'll just post in my table script here. So my table script is going to simply add a column outside of the ID that automatically generates to get me the vehicle ID, the days that I want to check, the time, the last successful check, who the owner of the object was, and then the notification URL that the Azure Mobile Services notification services will use. So now I've got a table in action. It's time to create an API that will allow me to interact with that API. So let's go back to our APIs. And we'll go ahead and create another one called charge state notification, plural or singular. Because again, we only, I don't want to have a user do multiple checks. That kind of, right now, while I'm just kind of, getting this out into market, I just want to do a single one. So again, we'll make it singular for all the good reasons that I mentioned before. So we'll make sure authenticated users. We'll say admins, authenticated users. Oops, not everyone. And authenticated users. And that's going to go ahead and create my API for me. It's going to chug along here. And we'll go ahead and get into our script here and do a little bit of editing here. So the first thing we'll do is do a get here. So again, same reason for the session. I want to be able to make sure that you only get the one object back. So even if you've given me multiple, I'll go prune that out later with another scheduled job. So I'll use some SQL to go ahead and get that back. Nothing too crazy there. The put, however, again, this is where I want to make sure that you're only going to send me one. So I'm going to go and check when you send me a new one, make sure it's the only one. If it is, I'll post it. Otherwise, I'll delete the existing one and replace it with the one that you've given me. So it's a last writer wins type model in this. And so this follows a similar template to what I did with the session. And then finally as well, the delete. which will make sure that, you're only deleting the ones owned by you. So let's go ahead and save that. And so let's actually skip back to the client. We'll come back to the scheduled job in a quick second here, and we'll add the piece to the client here to interact with that. So again, just to kind of take you down to the mobile services client here. Nothing too fancy. It's just basically going to invoke the API with the object, invoke the API, and pass in the object. That's really, nothing. That's really all you have to do on the API, and that's what we like on the client: lightweight, no thinking, just straight data handling, and then firing it off. And that's what I love. When they design this API, and I could do this with the HTTP client, and we look at basically about the same. Give or take a few extra lines to configure the HTTP client. So the big thing is going to be making sure that actually is all wired up. So I've got my unplugged notifications window. Again, XAML-wise, nothing too fancy yet. Luckily I've got my Pluralsight XAML courses all lined up for the 21-hour flight back, and we'll go ahead and enable the time here. So a couple of things that we wanted to do here. First off, we want to handle time a little bit differently. So the time on the client, in other words, what you're going to tell me is, go check for it at 7 o'clock your time. And as the server, I'm like, I don't know what your time is. Time is actually, depends on this thing called time zone. So everything on the server is stored as universal time. So we'll go ahead and convert that back to universal time. And on top of that, the API I designed in terms of the common library specifically says, I want this notion of zoneless time. And so I used a package called Notatime that John Skeet wrote to be able to basically drop all concept of time zone, so that if you're consuming my API from my common library, you know that you're not supposed to pass time zone in. And then days of the week is simply just a flag enum to kind of be able to pick off which days of the week you want it to check. And right now I've just got daily, weekdays, and weekends. I just got to figure out a way aesthetically of presenting a series of checkboxes to be able to say Monday, Tuesday, Wednesday, Thursday, and not make it look too ugly. But so right now I'm just offering kind of the common checks as to when most people will be interested. And then the next thing I want you to do is, because this is an app, I'm building a desktop app in this case, just go out and get the push notification URL off the app. And again, this is just standard Windows networking push notification stuff, nothing too fancy there. Then go ahead and call my client, persist all that stuff in, and then close the dialog box. So let's go ahead and run that, and we'll add a notification. Then we'll come back and kind of tie up the job, which is the more interesting part of this particular example. So it's gone ahead and logged in. Go to unplug notifications. We'll set it for sure right now. And we'll say it's every weekday. And we'll go ahead and hit enabled. And oh crap. Oh, error not found. Did I betcha. Either I didn't save the script or I called it the wrong thing. Let's do one quick check. So I just got an HTTP 404 from the other side, and that's probably because I called it charge instead of charging. So no problem. Unfortunately, there's no rename function, so we'll just do some cut and paste here. So again, this is where you're starting to see some of the newness of this API, or this service. Some of those kind of things that go beyond great demos, like renaming stuff, don't exist. But hey, that's all right. We all saw Entity Framework got a whole lot better once people actually started using it and giving feedback. So definitely encourage you as you use this to give feedback. I know I certainly have to the team around what I'd like to see there. So now we've actually got an API called charging state notification. Let's go ahead and run the app again and add that charging state notification, because we'll definitely need that here. So we'll go ahead and pick a time. We'll just do every day. There we go. And so now if I close the app, go back out to my Azure Mobile Services, I should see in my data table for charging state notifications a row here with my notification saying, here's my vehicle ID, here's the days of the week that I want you to check, and it's an enum, and I want you to check at this time, and it hasn't been checked lately, and then here's all my Azure mobile services piece, my Windows notification endpoint. So the really interesting part here in all this is being able to go ahead and execute a job. And so to do that, we need to go into our scheduler section here, which is technically in preview, but hey, it works quite well. And we're going to create a job here called Process Charging State Notifications. And I'll make sure I've got everything spelled correctly. And so you can see here, oh, hey, actually, can I do this now every minute? That's new. Cool. So now you can actually take that back earlier. Now you can execute a job every minute. We'll leave it at 15 for now because that's how I've demoed it. That's the nice thing about Azure is things are always evolving in the cloud. I don't need to wait and install Service Pack X to get new functionality. I do a lot of work around the TFS, and TFS Online's been great because we just get new stuff, and I don't even have to wait for the IT department to deploy, update, whatever. It just magically happens. So our next thing here is we need to actually go ahead and configure a script that is actually going to run this operation. Now, before I do this, I'm going to kind of keep in mind, there's, again, one of these things that became evident as we did this is the fact that there's some really great data here around when the job was last run, except it's absolutely not available to you as a script running it. It'd be really useful because especially if you want to check when the last run was and do some sort of data set selection. So to actually make this work, you need to create a table and track your own job status. So no problem, we can do that. That's something that we can do using the SQL Object Explorer. And so this time I'm actually just going to create the table through the GUI here, and in particular just to show you something so that you don't get startled by this like I did at first. So I'm going to go ahead and create the table. It's called job status. By the way, just kind of keep a note if you're working in the back end here, it's not DBO dot. Even though it's its own independent database, it uses the name of your Azure Mobile Services as the schema name. So that's just a thing to be aware of. Cannot find stored procedure. There it goes. Okay, weird. I did just hit the same command. Anyways, so I've created this table here, and if I go ahead and refresh the tables here, and while that's doing that, I will sequence up this. So you notice here I got a job status table. You'll notice over here I don't have a job status table. So just something to keep in mind, if you are going to go and play around in the back end, the reason I went, even though I was defining schema here and created it here on the management console, is because I want to be able to go see that. If I create a table in the back end directly, there's no visibility on the console. And I haven't quite figured out if that's a bug or if that was an intended feature, but just kind of keep that in mind. Because I did that once before, and I went looking for the table, and I was like, where the heck did my table go? I'm sure I created it. And sure enough, only through the SQL tools are you able to see the table. So now I've got my job status table. We can go ahead and write a little bit of an API. And I'm sure you're probably not going to want to watch me write all of the API over the next little bit, but we'll bring in chunks of it just so I can talk a little bit about creating that. So the first thing you need to know is, again, when you're writing this API, we're going to do it in JavaScript, but it's actually Node.js running under the back end. And what this means for you is there's actually a rich community of modules that have done really neat and interesting things. No different than being able to kind of call a NuGet package and saying, go get me this piece of functionality, bring it in. So what they actually just recently announced a couple of weeks back is Node NPM support. And so you can actually import these modules into your code and gain access to that functionality. So you're not limited by what natively ships in JavaScript. If you need a library that does asynchronous file I/O or does some sort of funky, kind of Twitter API wrapper, you can bring all those Node modules in and get access to those running on the cloud. The catch is that there's no command line interface here to do an npm install module X on the management portal today. So to do that, you basically have to do a git checkout of the mobile services endpoint and be able to add the module and then push it back up through the git module. Once you do, you've got access to some a whole range of functionality through the Node.js community. So definitely, don't limit yourself to what you can think of just with basic JavaScript. So the actual function name that you'll need to define here is equivalent to your job name. And so that's the actual function that's going to get executed under the covers. Now, because I'm actually going to do a couple of steps, and JavaScript's very asynchronous in its nature, what I want to do is make sure that I don't create what's called the Christmas tree effect. In other words, I have if blocks, or sorry, functions inside functions inside functions. And it's something that as you kind of first get into JavaScript, really kind of throws you off because you need to handle all these callbacks and you can't really block things in JavaScript. So we'll take a kind of a secondary approach to it. Now, generally I'd use something like a promises library to do that, but just for the sake of simplicity and not having to explain promises, we'll do it kind of through function call after function call. So you can think of each callback as an opportunity to more clearly isolate your code. So I want you to start off the job, initialize a couple of global variables or module variables, and then I need you to go ahead and get the last job run. Once you get the last job run, I need you to go ahead and update the last run with the current value. So this is me updating my current job status table. So no problem, we'll go ahead and do that. And I'll just, again, doing it, in this case, I'm just going to use an upsert in SQL. I don't know if anybody knows that you can do upserts inside SQL, but it's not exactly the world's greatest syntax, but it's definitely doable. Allows you to do an insert or update depending on status. So we'll do an upsert and add in that, and then we'll go ahead and get the notification candidates. And this is kind of some of the black magic in terms of selecting who the appropriate person is. So this was a really kind of just a logical one. This has nothing to do with Azure, but just thinking about how does time span dates? For example, if I'm running this job at 12:05 and I need to get the last 15 minutes, I have to think about my where clause and how that adapts over different dates. So that was really something kind of hard to scratch my head around to figure out what that where clause looked like. And that's really what most of this is doing, is kind of building that where clause depending on whether or not it spans two different dates, and then goes ahead and executes that query. The one thing I actually haven't solved, and I've got some notes in case you are interested in this, if you're trying to do notifications and you're thinking about time zones and daylight savings time, that actually adds a whole other dimension to this problem. And there's a couple of services out there that can help you navigate that particular aspect. So we'll go ahead and continue on. So we'll go ahead and get the charging state and then fire out notifications depending on it. So this is the part where I'm going to call the Tesla API. And so it's really easy. I just go ahead and construct my query string here just to say, go get my vehicle for the specific ID, and I want you to go get the current charge state. And again, this is where, this isn't my favorite API to call if you were here earlier. The fact that command is in here, command means absolutely nothing. This should just say vehicle 1234 charge state. But I don't know what Tesla's thinking, but hopefully they'll take some feedback on it. We'll package up the authentication cookie and the session cookie, throw that into the request, and issue the request out. And once we get the request back, we'll check the state, and we'll choose to send a notification and so on. So I know my car right now is not disconnected, so I'm just going to simply remove that clause there to check is disconnected, just so I can show you this piece in action. So let's go ahead and save this script in. We'll go ahead and run the job here. And hopefully what I should see in a second here, if everything registered correctly, is a toast notification coming through. And if not, unfortunately, the only way to debug right now the scripts is through log, console.log. It feels very old school, like trying, put, or print line 1 or print entry point 1. So let's just double check that I've got no typos here. And so it's running. Get notification candidates, select. Just hasn't issued the final call. So this is the Azure Mobile Services taking its sweet time. So, and it hasn't aired out. I'm just going to paste the entire code block in just to make sure, and just rerun that job, just to make sure that it wasn't just me. And if not, I'll go to the backup and show you it running on the production instance of Azure Mobile Services I have set up. See if the demo gods are on my side. Yeah, so the job is disabled. That's just the cron piece that kicks it off. You're allowed to actually, you can just initiate the job whenever you want. So yeah, you can safely ignore that particular piece. So let me actually, sorry, oh yeah, I'll just run, I've got the live instance here, so I'll just make sure that I've got my disconnected piece overridden here, and I'll run this instance. This should hopefully send the same message through. Boop, boop, boop. Yeah, I still got it logged out. Oh, there we go. It's calling. Sent toast. So it sent the toast. Sent the toast. All right, we'll wait for that to hopefully arrive at my laptop via the intertubes. Okay, well, we're nearly at the end here, so I'm not going to wait for the toast to come up, but eventually it does come up. Once it makes its way through the joy of the internet. Oh, there. Oh no, that was somebody else. All right, we'll go ahead and continue on. So just want to talk a little bit about what we learned about scheduled jobs as we're building that feature. First off, date time handling around notifications is really actually a tough problem. It's not just things like setting things as universal time, but it's also dealing with time zones and daylight savings time. And in particular, daylight savings time is probably the one that trips you up most, and I haven't actually solved and cracked that problem yet. I'm still working on it, and if you have, I'd love to talk to you about it. But basically, if I tell you to go check the car at 7 o'clock every night and daylight savings time rolls around, now I may be checking it, depending on which side you set it on, at 6 o'clock or 8 o'clock at night, because that's what the time zone would detect, because it's all just stored in universal time. So there's a couple of services out there. They're all actually, for the most part, pay services, so I haven't actually gone and spent too much of my own resources poking at them yet, but they will help you deal with the time zone issue. And so this is definitely something to kind of keep in the back of your mind. And the one thing I'm finding more and more as I'm building out these scheduled jobs is they're getting actually kind of hairy in terms of the actual script, because the jobs encompass logic, and that logic by nature is rarely just go get this and set this. Usually you need to evaluate some stuff, you need to make some conditional calls, and you want to apply all the good best practices of development against that. And so just kind of keep in the back of your mind that really this is just a Node.js server running Express. So I can actually go ahead and check out that code using the Git source control module, and then apply everything that I have today with Node, like Mocha, Chai, and Sonone, to be able to do testing against that. And so, this is, I could run a whole other thing on what I've learned around Node.js testing. But the good news is that you can apply the same level of quality control on your code, even though it's in the cloud there. And you do it through the Git ability to pull it out, use the Node modules, and then use everything that you've learned about how to do testing in Node to that. So once you've got notifications, once you've got job scheduling, things get really, really interesting. And the unplugged notification is kind of neat, but it's a little bit trivial. And so, kind of where this allows me to take and just kind of get you thinking outside the box are things like climate scheduling. For example, I want the car to start warming up in the morning before I go to work. But not only do I want it to just warm up, I want it to warm up based on the current temperature outside. So if the temperature is warm, I want the car to actually cool down. And I want it to cool down only within 2 degrees of the current temperature outside. And if I want it to warm up, let's say in the winter, I always want it to warm up to at least 18 or 20 degrees. These are really interesting things that you can do once you have access to scheduled jobs on the internet, access to an API, or actually access to multiple APIs. You can make some of these really other interesting scenarios. Another one that's come up, and this has actually come out of actual owners that were talking about kind of their use of their car, is they were complaining that they would go and hand the keys over to valet and come back and find that the car actually has another 100 kilometers on it because somebody decided to take it out for a joyride. I mean, hey, why wouldn't you? This is, Motor Trend's car of the year and yada, yada, yada. And I was thinking about this actually, not just about, kind of valet scenarios, but also, my daughter's only 2, but at some point she's 16 and she's going to want to take the car. And I want to make sure she's not going to go speed and, take it outside of the city limits or something like that. I've got this idea of basically putting a vehicle chaperone around it, because the API actually also includes a WebSockets connection that allows me to stream updates around its current location, current speed, and so on around the car. And so using that combined with the mobile services gives you a real opportunity to enhance the functionality. And then, of course, I'd love to take this across all the platforms. We're currently playing with Android, but like I say, the latest changes, all the changes in this tool sets in the last month have made it hard to kind of keep a working demo together. And then, of course, we'll be advocating Tesla to open up their APIs a little more. But lots of things you can do when you have the power of scheduled jobs and data and identity in the cloud. You can create some really, really interesting scenarios. In this case, it's for a car. But you can imagine there's more and more devices becoming internet connected. There's a lot of talk. The latest buzzword is the Internet of Things. So imagine what you can do when everything right down to your fridge, your coffee maker, and everything else has got an IP address and connected out in the internet. And then when you think about actually doing that, leverage some of these back-end as a services just to kind of get a quick start into enabling some of those really advanced scenarios. So lots of good things out there. Mobile services is still relatively young. And so I'd encourage you actually, to go out and poke at it, know it's still got some ways to go, and then contribute to the user voice community, because I know the product group is looking and watching that. Some of the things that I know that we're advocating for, and I'd really appreciate your votes, are things like a local dev instance, effectively, of Azure Mobile Services, because to be honest, debugging via console.log is not fun. I'd love at least Node Inspector access to the code running, so I can hit breakpoints and so on. So definitely, as you play with this or any of the other services, even if you don't pick Azure Mobile Services, make sure you feedback, because this is a very young field. And some of the guys I'd be looking at are Josh Twist and Chris Reisner from Microsoft. They're certainly blogging a lot about it, because they're in concert with trying to update the docs and get the information out there. They're also blogging about, here's some sample scenarios out there. I will be open sourcing this once we get all the kinks worked out, probably post Win 8.1, because there's a lot of XAML stuff to figure out and make sure everything resizes. And like I say, just another plug, if you're a XAML expert, I'd love to hang out with you on Thursday. I've got a bunch of questions around XAML over the last couple of weeks I've been building up. Otherwise, check out some related content. If you want to know specifically more about Azure Mobile Services and see some more of the generic demos about kind of the core functionality, or more importantly, some of the cross-platform pieces, definitely check out some of the other content out there. And of course, fill out an eval, as you've been told, I'm sure, a few times, and win a mouse. Thank you very much.